now we'll go into the revision for the empirical formula calculations. So we look at this example. These are similar to the previous topics that you have to calculate number of carbon, hydrogen, and oxygen. So we have 1, 2, 3, 4, 5, 6 carbon. Then hydrogen, we have 1, 2, 3, 4, 5, 6, 7, 8. Then we have 1, 2, 3, 4, 5, 6 oxygen. Okay, so the element that form will be carbon, hydrogen, and oxygen. The molecular formula will be the C6H8 and O6. The relative molecular mass, you just calculate 6 times carbon, which is 12, 8 times 1, which is hydrogen, then 6 times oxygen is 16. Then you will get the mass will be goes to 176. What type of particle found in the vitamin C will be a molecule. Then from here, this is the one that the new calculation. First, percentage you can directly convert to 100 grams because you assuming that you have 100 grams of sample. So 100 grams equals 100%. So 2% equals to 2 grams, 10% equals to 10 grams. So technically you can direct change everything to the a gram. Okay, the percentage change to gram. Then divide by molar mass for carbon is 12. Then after that you get 3.4. Then 4.6 divided by 1. Then 54.5 divided by 16, you get 3.4. Then after that, you find which one is the smallest number. So all will divide by 3.4. Okay, then to get the ratio, you times 3. So the ratio will be 343. Then calculate the mass of the 0.05 mole of the vitamin C. So same now, you get put the mole is 0.05 mole, the molar mass is 176. So the mass would be 8.8 grams. Calculate the number of atom in 35.2 grams. So I got 35.2 grams. First, use the mass or molar mass to find the mole first. Then use the particle to find the molecule first. Then after that, because in here we have 20 atoms, so the number of molecule times 20, you'll get how many atoms you have here. Okay, this is another type of questions, slightly different, that it has 20% of hydrogen, means the carbon will be 80%. Then if you use this to find number of mole, divide by 6.66, you'll get the ratio is 1 to 3. So the empirical formula will be CH3. Then in here, he tells you that 6 grams will occupy 4.48. So what we do is, since we have 4.48, we use mass or molar mass, volume or molar volume to find your number of moles. So you'll find 4.48 dmq divided by 22.4, you get 0.2 mole. Then you see this one 0.2 mole is here. The mass I have is 6 grams. Then I'm able to find my molar mass. Then my molar mass is 30 grams per mole because molar mass has unit. So it means the relative molecular mass is 30. Then just now, the molecular formula is CH3. So empirical formula is CH3. Then molecular formula will be bracket N because it means I don't know it's how many N. But I know the mass is 30. Then I put in CH3 bracket N equals to 30. Then carbon is 12. H is 1. I will get N equals to 2. Then I can bring in CH3 bracket 2. I will get C2 is 6. Then X gram of iron combined with this amount of oxygen. So you put X gram, this one. And the ratio is 2 to 3. So you find X divided by 56. 5.04 divided by 16. I will get this number. Then to get 0.21 is very simple. You divide by 3, then times 2. You'll get 0.21. So X over 56 equals to 0.21. Then you're able to guess X equals to 11.76. Okay, this is another question. This is the mass of manganese. This is the mass of oxygen. Then the number of mole equals to mass or mass. So you divide by the I don't know the mass. So I can put in as calculate the oxygen first, divide by 16. Then the ratio is given is 1 to 2. So technically, like this one, you divide by 2, then you times 1. Then you get the mole should be equals to 1.15. Then divide by n. Then from there, you're able to find your n equals to 55. Write a balanced equation for this thing. Manganese plus oxygen, it becomes manganese 4 oxide. Then the equation is already balanced. Hydrocarbon, okay, hydrocarbon means only contains carbon and hydrogen only. So it has this amount of the carbon, means the remaining one will be the 100 minus 85.7% will equals to 14.3% will be hydrogen. So same thing here, you find the number of mole first, 1 divided by 12, 1 divided by 1. So divide by the small number is 7.114. So you divide, you get 1, then you get 2, the empirical formula is CH2. Then same with the previous question, it give you gram and give you volume. So first, use the volume to find number of mole first, 0.6 bm cubed. You divide, you get 0.025 mole. Then after that, 0.025 mole, the mass is 1.05. Then you can find your molar mass will equals to 42 gram per mole, means the RMM relative molecular mass is 42. Then we have this as what we call the empirical formula. So molecular formula will be bracket n, and this bracket n is the actual formula mass, actual formula. Then actual formula mass is 42, so you can equals it. So C is 12, H is 1, times n times 42, you'll get n equals to 3. Then substitute n equals to 3 inside, you'll get C3H6. Okay, this is another type of questions. This one's slightly tougher questions, so you try. Okay, a chemical, it has carbon, hydrogen, and oxygen. When it burns with oxygen, okay, you produce carbon dioxide gas and hydrogen gas. So the information we have now is this much. I have 2.078 gram, and I have 1.2738 gram of the what we call the gas. Okay, so the main thing now is okay, see our carbon dioxide, right? Is like this. This is 12. This is 16. This is 16. So if you look at the percentage of carbon in carbon dioxide gas, so carbon dioxide gas, it has carbon only. The percentage of carbon by mass is 12. Divided by the carbon dioxide is 12 plus 2 times 16, will equals to 12 divided by 44. Means 44 is the total mass. Out of this to 44, 12 is carbon. So since we know the mass here, okay, example, let's say if you calculate out 12 let me calculate. 12 divided by 44 means like about 27.2% is carbon. So how do I get the carbon here is I take the 12 divided by 44 times the mass here, means this is the mass of carbon dioxide gas. 27.23% of in this carbon dioxide gas is carbon. Then the rest, right? Let's say if you look at, we minus off 100% minus the 27.27 will be 72.73% is oxygen. Because from carbon dioxide, carbon is 12, oxygen is 16. So the majority mass will be oxygen. So you use a ratio method, you will get carbon is about 27%. So I'll get 27% of the 2.078. I'm able to calculate only this much of is come from carbon. Okay, same thing we do with the hydrogen gas. Water. So water we have H2O. So this is 1, and this is 16. So the percentage of hydrogen in H2O, the mass is 2 times 1, the hydrogen mass, divided by 2 plus 16, will equals to 2 divided by 18. Okay, so out of 18 mass, 2 is from hydrogen. So you can use this method to find out in your 1.2738 gram, how many gram belongs to hydrogen? Okay, I'll get only about 1.142. This one calculation, it has then after that, the calculation number of gram oxygen, I think this one we have calculation. Let me check the calculation error first. Oh, this is 0.1415. So this one 0.1415. Then I will minus off. You see, this gram inside got carbon, got hydrogen, got oxygen. So now we found that the carbon is this much, and then my hydrogen is this much. So the remaining mass will be my oxygen. So I will minus off to get my oxygen mass. So we consume another round for the mass thing. Okay, we still do a conclusion. Out of, in this compound, we have C, we have H, we have O. Okay, this much. Then when you burn completely in oxygen, you will get 2.078 of carbon dioxide gas. Out of this, right, in this much of carbon dioxide gas, inside got 0.5677 gram of carbon. Okay, so technically we know that when you burn the oxygen, you actually produce this much of carbon dioxide gas, and this is the amount that in the what we call the carbon. Okay, then we also produce this much of water, 1.2738 gram of water. Out of this, we have about 0.1415 gram is hydrogen. So you see, because this CHO rare oxygen will produce this much, then we're able to trace back this much of carbon inside and this much of hydrogen. So these two, the mass is inside here. So 1.08 minus this number, the remaining will be my oxygen, which is, at least we calculated is 0.3794. Means these three mass add up together will go form back your 1.876 gram of carbon dioxide. Okay, so from there, you will calculate the number of mole, divide by 12, divide by 1, divide by 16. Then which one is the smallest number will be this one. So all divided by 0.0237. You'll get the ratio is 261. So the empirical formula will be C2H6O. This question considered was one of the hardest questions that it's very analytical questions that. So it came out in school exam before, so at least we run through this one. Okay, so we can go back to this. Okay, for the final formula you found is C2H6. Oh, then after that you go come out this much of the compound occupied this one. So we can calculate out the number of mole, 2.4, I get 0.1 mole. Then the mole I put in here, then the tube 113.8, then I will get the molar mass equals to 138. So we know the empirical formula is this one. Then the molecular formula in bracket N, then the mass is 138 now. Then after that, we put inside here, we will get N equals to 3. So the actual formula we found will be the bracket N changed to 3, then this is the answer. So we can try to reverse back the calculation. Okay, this is the brief idea. Plus oxygen, it becomes carbon dioxide gas and water. If we do balance equation, so it will be 6 carbon, hydrogen we have 9. Okay, so how many oxygen we have here? 12, and then we have 9, total is 21. So 21, we have 3 here. We need about 18 here, so it's 9 oxygen. So now I try to calculate out, see whether is it match the chemical or not. So we have 1.0876. Okay, right now here first. 1.0876 gram. Then it produced 2.078. 2.078 gram. Then the water is 1.2738. I'm trying to reverse back the calculation. Okay, so now we try to find the number of mole. Okay, look at this, the number of mole is a number of mole of C6H18 and O3 equals to mass or molar mass. So the mass here is 1.0876 divided by the molar mass is 6 times 12 plus 18 times 1 plus 3 times 16. Then we take out the calculator. So it's 72 plus 18 plus 48. 138. Then for that, 1.0276 divided by 138. I'll get 0.00788 mole. Then we try to find the 2.78 divided by carbon dioxide is 44. Okay, carbon dioxide number of mole is equals to 2.78 divided by 12 plus 2 times 16. I'll get 0.04722. So right, 0.04722 mole. Then number of mole of water equals to 1.2738 divided by water is 2 times 1 plus 16. I'll get 1.2738 divided by 18. I'll get 0.0707. So you see the ratio, we just do a final check, just for you to understand that these original questions, okay, it has this much of the compound. When it burned with oxygen, it produced this much of carbon dioxide gas, this much of H2O. So we check the mole ratio, is it correct? The ratio of this one is 1 to 6. So you try to take this number times 6, see whether you get the number or not. 0.00788 times 6. Yep, you get this number around there at 0.04728. Okay, then you try to this one, the ratio between this one is 9. So 0.00788 times 9. Okay, you actually match the number 0.0709. So this is the idea that at the beginning of this question, but this question only came out once in one of the reference book. Then after that, got some school teacher, they saw it's quite good question, so they put it inside the school exam. Okay, so this is how it works out. That these is roughly the questions. Okay. Then we move on to the next question. Farmer use the chemical to improve. So this is the fertilizer. Then we have this one to reduce the acidity of the soil. So relative molecular mass of ammonium phosphate is 149. Calculate percentage of the mass in here. So here you can see in here we have 3 nitrogen. So the percentage will be 3 times 14 because I got 3 nitrogen. Then divide by total mass is 149. I'll get 28.2%. Okay. Then the farmer use another fertilizer. So they give you the percentage. So first you calculate out you assume it's 100 grams first. Then you divide more. Calcium is 14. Then hydrogen is 1. Phosphorus is 31. And then oxygen is 16. Then you find which one is a smaller number. This is a smaller number. So all of them will divide by 0.4275. Then you get the ratio is 1428. So the empirical formula will be C8 AH4P2O8. Okay, so this is the draft idea. After that, citrus fruit have orange and rich in vitamin C. So this is ascorbic acid rich in vitamin C. So we check how many carbon now. 1, 2, 3, 4, 5, 6. Then hydrogen we have 1, 2, 3, 4, 5, 6, 7, 8. Then your oxygen we have 1, 2, 3, 4, 5, 6. So the molecular formula will be C6H8O6. Then the empirical formula is 343, and the ratio of 686 will be 343. Type of particle form as ascorbic acid is molecule. So it has this much of the ascorbic acid. So we have to calculate mass divided by molar mass. I will get mole. Then I want to find how many mole. That will be the answer. So divide by molar mass. So molar mass would be 6 times 12. This is my C6. This is my H8. And this is my O6. So this is the draft idea.